Hello and welcome to the stream. So we are kicking it off again today with the MV API, and we're just going to dive straight into code today. I wanted to make sure that we just kind of focus so we can really get into the API and focus on the CLI tomorrow with any luck. So where did we get to last time? Hello. Thank you for joining me. I am great. Thank you. I am having a wonderful day. I've just pushed the code up to GitHub. I'm going to drop that in the chat for anyone interested. And I'll just show that on your screen there as well. It is github.com/juststevking/nv-api. So go check that out if you want to drop a PR, if you want to play with it. I didn't get around to it yesterday. My afternoon kind of exploded. I apologize if the internet's being a little bit funny. It seems that every time I decide to go live, the internet decides to play up. But we will battle through and we will get this done. So what have I been doing? I have been able to register a device, which is fantastic. I can log in and register now. I'm using the kind of slightly clean code approach. So if we come down to my controllers and look in auth, in our login controller down here, we've got our token service. We authenticate the request the same way that Laravel Breeze does, exactly the same way. It is the same code, just that is the only bit different. Instead of using the input, I'm just getting the string values. And then we use the token service to create a new token. We return a response object saying that the message is successful, and we pass that token back. So the action of logging in and authenticating is something that really needs to be a synchronous action. You don't want to push that to a background thread. So that is why we do it this way. And we're authenticating by the auth ID there. That's the only bit of kind of unclean code that I've got right now. Not super happy with that, but it's something that I'm going to accept. And then we're just going to get the user agent from the request for the token's name. Because the idea here is that each time you log in, you're going to be logging in from a device and you want to get the user agent. In the CLI, we can create a unique user agent name for each request that we can then set for every time that we are talking. So it just kind of marries things up really nicely, ties it back to the device, and it's all good. So let's go look at this service. So the token service, what does it do? We're going to pass through the ID for the user, the name of the token, and any potential abilities you might want to pass through. So by default, we're just going to say, anybody who logs in gets all abilities because of the type of application we're building. We then talk to our token repository to create a new token. Come down to here. I've refactored this so that the has database is a trait that I can apply across everywhere. And the reason I've done that now is because it follows the rule of 3. So what that basically means is, let's say you're doing a similar bit of code like I am here, and I've used it twice. It's not too bad to keep it, that repetition in 2 places. Soon as it gets 3 or more, it starts to get, well, why don't I just abstract that? Why don't I make that, composable in this case, where I've got a trait? You could create a abstract repository and extend that, but I always prefer to go for composition over inheritance personally. It's just the way that I like to do things. You obviously don't have to follow that approach. Do it your way, but that's why I've used a trait here instead. And it's a perfect use case for a trait. So then we've got create, where we're going to go user find and create a token. So we want to get the user record and create that token. Now we could, in theory, go a little bit cleaner here. However, I am happy with this approach. The reason I'm following this pattern is because I'm demonstrating it. Typically, I would maybe do something a little bit different. However, this works for me. I know it's going to just work. I'm happy. And that's what the stage you've got to get to. You've got to be happy with what your code is doing. If you're not happy with what your code is doing, then why are you writing it? Is the way I see it. And then let's look what else I've done. Services, we've got the user service itself. So we want to go to the user service when we want to register. We say, okay, here's our service, and we want to register. Now, this is where that language changes. Sometimes you've got the same method between service and repository, and it almost feels pointless. However, this action is a perfect explanation, because what we've got is we've got a user service and we want to register a new user. To do so, we need to talk to our repository. And because the user repository is that kind of gateway to our data access layer, we're saying, okay, we want to create a user basically. But at this stage, we are saying we are registering the user. So it's that nice language change, because then what we can do is on the user service, let's say we want to add a new user. We could, quite easily just say public function, add user. This would have a new user also passed into it. Return a user or a model, and we can say this repository create where the user is the user. And then we can add our dot block there. And it's an abstraction away from your abstraction almost. It's giving you a kind of a way into your repository, into how you want to interact with that database layer in the background. And because of that, you want to keep the naming almost purposeful. You might end up with some code repetition here. I could quite easily do that just to proxy it, because it's just pointing to the same place. But I'm going to be deliberate, because that could change in the future, and I don't want to kind of risk not doing it in this layer. So that is our user service, our user repository. We're going that way for multiple reasons, mostly because we can, I guess. And hey, Rob, you missed yesterday. So today, what we're going to focus on. So we got to registering a device. If I come over to the client here, we can register a device. We are happy. We can say, here's a name, type, operating system, architecture, and identifier. It's all good. If I send that again, the identifier has already been taken. No problems. Hey, Benjamin, how are you doing, my buddy? So what's next and what's important for our CLI, I guess, is perhaps going back to look at our models a second. Let me just move PHP Storm this side so it's a bit more accessible. So if we look at our models quickly, we can create a user. We know that we can log in. I've added this static method here to make kind of, I suppose, IDE click through a little bit nicer. I personally add these manually, but you can use the Laravel IDE helper package to achieve this, and it will work perfectly. However, I do this way because that's just me. So next thing we want to do is we've registered a device. Then what we want to do is say, okay, so now that you know about my device, what's important next? I'd probably say it would be my shell. When you're setting up a machine, what do? You set it up under your user account. You then get the shell the way you need it to. You then install the packages and the apps that you need. And then you might have installed the editor as part of that app, or the editor could be something else. But for me, it's always a shell next. So what we're going to want to do now is, okay, I've registered my device. I've got my device up there. It's all good. Now let's register my shell. So that's what I'm going to go for next. This isn't going to be complete for tomorrow, but it's going to be enough that we can work on our CLI app to kind of try and get, our device registered and our shell uploaded. This is the aim here. So how can I do that part? Well, I can come down to shells and I can say hosts. I want to register my shell. Now, I did mention this yesterday, but for anyone who didn't tune in yesterday, I'm going to repeat myself. I could just do a post to the slash endpoint here, because shells here it does have a prefix of shells. However, I'm not building a CRUD API here. I am building a REST API, and I want the language to reflect the action you're trying to take. I want to be, purposeful on that one. When let's say I want to extend this later on for admin usage, I might do a post to, not set container, name. I want to create a new shell, in which case I'm talking about two different things. I've got a shell here. Now that is going to link to this. The shell config here, that is what we're registering. We are registering our shell configuration at this point. So it's not kind of just wrapping my resources in JSON endpoints. It's building that purposeful API for the reason you want to do it. So for now, I'm going to delete that because I don't want that right now. I want to focus in on this register here. So I can come over to controllers, create shells, and I'm going to create a register controller. So I've got my register controller. What I'm going to do is I'm just going to pop that in here. Shells register controller. Then I'm going to import this namespace to make my code a little bit nicer to look at. And there we go. As I mentioned yesterday, the reason I import the namespace here is because then I don't have to import every controller. Just a nice and clean way to do things. So we can close device, shells, user, and routes. Open up our terminal and let's make a form request. Make request, shells, register request. Okay, so that is going to complain. So let me just quickly add that invoke method. And try it again. And there we go. We are good that time. So this is going to have that register request from shells. So we can go like that. Let's go click through and fill it out. So we're going to declare script types. This won't be extended, so we can make it final. And I mentioned this to someone this morning. I kind of have like a checklist in my head for every class that I work on. When I know it's done, I run through this checklist and then we're good. It's just the way that I like to work. So what I need is I need the shell. All I need from that is a name. So we can do this. The shell is when we create or register a new shell, we need to say, okay, this is my ZSH shell. This is my bash shell. This is my new thing that I'm not really sure about shell. And it just allows you to kind of work, keep it all together. Max 255 because we are using a varchar. Okay, so at that point, we've registered our shell. Now we need to look at the shell config. So we're going to have data coming through. And this is going to be required. But now I'm going to keep it as a string. What I'm imagining, I'm going to be sending like some sort of kind of text blob over. I might do some parsing and processing in the background on that one. I'm not too sure yet. We'll get around to it. That in the database, I believe is text. Let's go double check that one on our shell config. No, it's JSON data. So what I need to do is kind of JSONify it a little bit, maybe. I'll come back to that tomorrow, perhaps when I start working with trying to register a shell, I think, just so that I can figure out the best way to do this. And that's literally all you need at this point. we can register our shell at that point. So let's come on over to our payloads. We're going to say that we are registering a new shell. So we want to create our DTO at this point. So construct, we're going to have a private read-only string of name and a private read-only string for the data itself. We're going to have a way that we want to pass this back to the database, which is to array, which will return an array. And this array will have name, this name, and then it will have data with this data. We might do some casting and kind of transforming a little bit later on. Right now, I'm really happy with just doing it this way, and we can kind of work on that one. So name is going to be returned as a string, and data is going to be returned as a string. I'm going to need this for my next part, where I come down and add the static create method. So public static function from request, where we accept an array of data from our request, and we return a new shell. So I can now drop that in there. Not return an array, my bad. Return a new shell, where the name is data name, and the data is data. Nice and simple, good to go. So in our register request again, we can come down and add another method, public function payload, which is going to return a new shell. And I can return a new shell from request, passing through the data from our request itself. So the name is this string name to string, and the data is this string data to string. We can now work with that. At this point, we can go, okay, give me my request and get the payload. And that gives me the new shell payload that I wanted. So what else do we want to do here? Realistically, registering a shell can be quite asynchronous. We don't care about getting a, cool, here's your shell object back, because this is kind of like a fire and forget sort of endpoint. We just want to go, okay, I've got my data from the CLI. That's what's controlling this flow. Send it and let me carry on. When if I want to update it later on, that's great. I might want to update it from a different machine. We're all good. But this is where we're going to want to dispatch a job. And when you're building any API endpoint, you really want to kind of think about the actions that you're doing and why you're doing them. Cool, that is authenticated. Just wanted to double check that. Okay, so let's make a job. Shells, register new shell for device. I like to have my background jobs quite wordy, so they're descriptive. What am I trying to achieve here is what I kind of want to see. Because when I come to this controller, I know, okay, so at this point I'm registering a shell. Cool, that makes sense because of that API I'm building. But when I just say dispatch new register and everything is namespaced and really short, I don't know what's going on. So I want to say that I want to register a new shell for device. Perfect. So at this point, I need to know the device. So I need that device ID within here. So this should be required. It should also be a string. And it needs to exist table devices. Now, if I open up device, it will be the identifier column that I need to check against. So I want to make sure that when I'm doing this, I'm sending that across. And part of a CLI process is going to be, okay, I want to initialize my CLI. Here's my API token. We're good. Then I want to register my device. Excellent. I got that payload back. Add that to my config because I've registered my device. It needs to be saved to every time I'm using the CLI. So it's always kind of building on top of everything. So register a new shell for device. Let's have a look at this quickly. So let's declare some strict types. We will make this final because it won't be extended. We can PSR 12 it by dropping these on each line. Clean that up and say, okay, let's use constructor property promotion. It's got to be public to access it, but it can be read-only because I don't want it to be changed in any way. At this point, what I'm going to want is the device to be passed through and the new shell payload to be passed through. That allows me to access everything I need within this job really easily, nice and clean. So my device is going to be request string device to string. And then the shell I want to pass through is going to be the request payload. Then once that's dispatched, I can return a new message response where the message is going to be, we have accepted or we are processing your request. At this point, you're kind of trusting the API to do what the API needs to do. So we want to return the status code for accepted. Because we've accepted the request, we haven't created anything yet. That is a background process. You can type in that one. That is all good. Let's add our doc blocks. Now, this is a global helper, which isn't ideal for me. Like if I click through, I could just say inject a pending job or create a new pending job and handle it that way. But I'm not going to chase the rabbit hole too much with clean code on this. So we're processing your request and we're dispatching. Global helpers on the devil. They're great to use. They shortcut things, make things a little bit easier sometimes. So I'm just going to stick with that one. But when you look at this code and you take over or start working on this API, you're going to come here and you go, okay, so how do I register a new shell? Cool. Shells register, go to the endpoint. Okay, cool. So I validate it. Then I'm dispatching a background job where I'm registering a new shell for a device. Awesome. That's a device, and that's how I'm getting the device. That could change. Could use a header. We'll see. And then the shell is the payload from the request. I can click through and understand how that payload is built. And then I'm returning a response. We're happy with that. Awesome. So what we want to do here is execute the job. To do this, we're going to want service, and we're going to want to create a new service. We're going to create a shell service. And this service is going to be like the gateway to multiple repositories, either the config or the shell itself. So we can register a new, or we can register a config, kind of balance both. So this service needs 2 repositories. So let's go ahead and create those. Shell repository, go. Then we can say use has database. And then we're just going to shortcut this one to config repository. And again, this will use as database. So the first thing I'm going to want to do is create a shell, so I get that foreign key back. So public function create, We're going to pass through a string name, and we're going to return a model that is most likely going to be a shell. So we can return this database transaction. We're going to attempt it twice, and the callback is going to be shell query update or create. The attributes is going to be the name. That's all we need. We don't have to pass values. That could potentially fail. So we will make sure that we add that throwable there. So now in our shell service, we can pull this in. So public function struct private read-only shell repository, and we're just going to call that shell this time because that's a kind of minor part of this. And then the second one is private read-only config repository, and we're going to call this one the repository. Right, so let's make that read-only. The shell repository for now is good. My config repository is where we are going to create a new config, I guess. So what do I want to pass into here? Let's get the string for the data. We're also going to want to get the string for the shell and the string for the user. We're kind of going to want all of those things. This will return a shell config model. So here we can say return this database transaction. Going to attempt it twice. And the callback is going to be shell config query create. So the attributes that we want to pass through are going to be data, shell ID as shell, and I was wrong. That actually needs to be the device. So then I can say the device ID I'm registering this shell on is this device. Add this up here, and then we can look at tying it together. So this shell service, we want to register a new one. So public function register. We're going to want a few things. We're going to want a string for the user. No, device. Got that one again. And then we're going to want the new device. No, new shell. Sorry, again. One of those days, I think. All right, so I can draw up that. I don't need that. And that will return a shell config, which is a model. So how do we want to register? So firstly, we need to register the shell. Then we want to register the shell config for our device. So the way that we're going to want this to work is, hey, Junior, how you doing, buddy? Is down here, we're going to say public function register shell. That's going to accept a string for name. And that is going to return a shell. So we can say return this shell, create. The name is going to be the name. There we go. That could potentially fail, which is fine. Exceptions are important. So we can say, okay, so our we're just going to call that model for now. And we're just going to say this register shell. And we need to get the name at this point. So what we're going to want to do is say name and data. We are going to get this from shell to array. So we can pass our name through. Then we're going to want to register the shell config. So return this repository, create. The data is data. The device is device. And the shell is model get key. And that should be it. Sort those arguments quickly. And there we go. This could potentially fail. So we'll add that to it. So let's walk through this, see what we're actually doing. So we want to pass through the device and the payload. That's all good. We can do that. Then we want to get the name and data out of the array for the shell. We want to create the shell itself. And then we want to create our config. So we're creating our shell down here, creating our config up there. Next, we want to come to here. This is going to get the shell service as the service. And then we are simply going to say service register shell, register. So the device is this device. And the shell is this shell. All ties up, very little hassle, and it is good. We want that, if that fails, we don't want to try and catch it. We want it to fail in our job so that we get that failed job coming back. And that is now all good. So register new shell for device, shell service, register controller. At this point, we are good. We can register our device. We can register our shell. It's going to be the same pattern for like literally everything else. We want to register what we have. So the next thing is perhaps let's look at device syncing, because that's one where we actually want to get information instead of just posting information. And we want our CLI to be in charge of going, okay, now what do we want to do with this information? So at this point, we're going to go to our device and we're going to say root get sync name sync. So if I come to the README quickly, and just come over to this. So what we're going to have is we want to be able to say MV register to register our device. So MV shell register. And we're going to want to do this to register our shell. We've got that pretty much done on the API side. Then what we're going to want to do? Well, MV sync makes sense, right? Sync our device. And what our device wants to do at this point is go, okay, so give me my shell config, give me a list of my packages, give me everything. Give me everything I should have for this device. And then I want to say, cool, I've got all that information, don't need the API anymore. I can spawn off Go routines and say, okay, so sync the editor, sync the packages, sync this, do that. And the shell can just go ahead and do all of that for me. I mean, I could say like shell sync, maybe that's something I'll add in the future. Right now, I'm just going to focus on like a global sync as it is. So let's have a look at controllers, device, and we're going to create a quick sync controller. So this needs to have an invoke method. We'll get the request, and we're going to want to do something with this. So let's have a look at this, and we're just going to say devices, sync controller, all good. So what do we actually want to return here? What's important? Now, if this was like a consumable API by multiple different things, I'd be going JSON API, no questions asked. I'd be wanting to have filters and sorts and all sorts of kind of cool stuff going on. Right now, for my proof of concept, I just want to get that data, return it, and let the CLI handle it. So we want to say, okay, basically, give me the device, get the device info, return a response. That's kind of what I want to do here. And what I think we should do here is we kind of want to do a couple of things. We want to do ownership and policies to start with. Can this person get the details for this device? Yes or no? We're going to need a policy. Getting the device information, we can use our repository and our service for that. And then returning a response, we've already got a package that can handle how we do responses. So we're good. So give me the device, give me the device info, and return a response. Let's first off make a policy. Make policy, device policy, and the model is going to be device. So we've got our device policy now. So let's open that up. How do we want this to work? Well, to start with, I'm going to remove anything that I'm not going to use right now. All of that. And that. Which means I can just add this final here. Okay, so on the device, this is actually owned by a user. So what all I need to do here is say return whether the device user ID is the same as the user ID. It is that simple. This needs to be registered. So in my auth service provider, I can never remember which way round I go with this. Let me go double check. Creating policies, class policy, awesome. So our device uses the device policy. We're registering our policies already, so we're good. So in our controller, we want to look at how can we do this. Typically, we'd use the gate facade and say, is it can? Let's go double check the docs, see how they do it. Today, writing policies, policy methods, policy response, gate inspect. Gate allows method will return a simple Boolean. So allows ability is going to be view. And we want to get the device at this point. So we need to kind of do some querying in advance. So how are we going to get the device? We could use root model binding, where we just pass through the identifier, and that could work. However, I don't want that to be in the URL. That is something that you shouldn't share publicly like that. So what I need to do is what is the device identifier? And in reality, when I'm doing this, I think perhaps a header would be best so that it can come through as something like X NV device, something like that. Something clean, something easy to access. Just gonna have a quick drink and we'll crack back on. If anyone's got any questions at this point, throw them my way. Otherwise, we will just carry on as planned. Okay. So what we want to do here is have a nice way to access that header. Now we can do it in line. We can say that our device is, request header where the key is X NV device. Then if we don't have that, then we can fail, simple handling. However, do we want to get to this point? Probably not. So what I think we should do at this point is maybe create a middleware. So make middleware, and we're going to say device aware middleware. So let's open that up. Our device aware middleware. This is something that is going to be aware of the device. Going to drop that off. So at this point, if the request doesn't have a specific key of XNV device, we want to fail. We want to throw a new exception, which we are going to create. Let's make that exception now. Make exception device not defined. So let's say throw new device not defined exception. Message is going to be ensure you send the device identifier as a XNV device header. Now, the code that I'm going to want to throw on this one will go status. And this will be a bad request. You've missed how you're meant to send this request. And if we do have it at that point, we kind of want to say request. I kind of want to use attributes, but attributes never work nicely. Like you can use a session, I guess, or cache. What's going to make sense here? Like, do we want to keep looking this up? In reality, no. So cache forever, anytime we get this kind of request header coming through, header, the key that I'm looking for is XNV device. I want the value returned. Function So is that a callback that I need to pass through? Let me just double check. Mixed value. No, it doesn't matter at that point. Okay, so what I want to return here is device query where the identifier is that. So we can do something like identifier equals that, and just use the identifier first or fail. But what we want to do, we want to allow sort of eager loading here, because most of the time when we're getting the device, we want to get extra things. So if we look at the device, we can start looking at what else we have. We want to get the configs. That's for sure. But when we look at the configs, we're also going to want to get the shell that's attached to that. So configs.shell. Once we've got that, we want to carry on. So we've got 2 points of failure for every request here. If we don't set the device ID as a header, we want to fail. You know, we need that device ID to know who you are. Great. Once we've got that, we want to cache based on the device identifier, the device itself. We're going to say, okay, give me the device for this identifier. If we fail at this point, they've made a bad request again. So 404. You know, this device doesn't exist. Something's gone wrong. Sorry. This, of course, is rate limited. Like all API requests, it is rate limited, so you can spot those bad actors. If it is found at this point, we can get it. It's good. So that in our controller, we can say our device is cache get that header. And then we could pass this device back through to here to check the gate. So what's going on here? Let's kind of walk through it, because it's kind of, there's several loops that it can go through, and I don't want it to get too confusing. So our middleware is going to say, you haven't given me the right header. Can't help you. You've given me the wrong header. Sorry, I can't help you. You've given me the right header so I can get that information, but you're not allowed to see it. Can't help you. Giving me the right header, you're allowed to see it. Here's the information. So it's got that nice kind of flow. We don't have to do multiple lookups. We're saving that in cache to get it. And the reason we're saving it forever is because any time that device makes that request, we want to get it back. We can do a lot of cache invalidation in this. So if you upload a new config, invalidate the cache for that device identifier, send it again. So this point, I've already got the device and I've got the device info. So all I actually need to do is return a response. Now the response I want to return, let me just root middleware. I need to register this, so I need to open the kernel, and I need to register the device aware, which will just be called device aware middleware. Done. So that over on here, I can just say device. Now I need a group. I will have a static closure within here, turns void. I can now move this within here. Oh, give me that. Good. So now anytime anyone tries to sync, I know it's going to run through that middleware and check it. I can close that down, close all of that down, sync controller, now we're good. So we want to create a resource at this point. So make a resource, and we're going to create a device resource. Then we're going to make a date resource, config resource, and a shell resource. That is the main things we're doing right now. So here we want to say return a new model response. That model response needs to be a new device resource. The resource we're going to give you is this device. We'll keep with the default 200 response because we got it, we're good. This can then return that model response as a type, and that is now closed off, which means all we need to do is fill these in. So we can declare some strict types. This won't be extended, so we can make it final. Now we just need to worry about transforming. So we want to get some information back from the device. So first thing, we want to make sure that we can type in properly, right? So we can say property read device as resource. So let's open this over here and put them next to each other. Zoom out a little bit so we've got good visibility. So we want to go and say, okay, so the name of our device is this resource name. The type is this resource type. Operating system is this resource OS. Architecture is this resource architecture. We can pass that identifier back. Whether it's our default device or not, we can pass that back. And that is when we get to the next thing. So last synced is new date resource. And the resource we are going to pass through is this resource synced at done. So let's go fill that in. This will be strict type, won't be extended, will only ever be used. The array that we want to return back from this is going to be pretty specific because it's something that we're going to use again and again. So a property read, we're going to pass through a carbon instance as a resource. So that when we say, give me the human format, this resource diff for humans. And then if we ever want the string format for any reason, we can just say to date time string. Done. That date resource will work. So our device is going to have many configs. So what we want here is configurations. And we're going to have a config resource collection. The resource that we're going to pass through to that is this when loaded, because we might use this resource elsewhere. Resource, this resource configs. Can't use, my bad. There we go. Oh, I need to pass that to this name, sorry, as a string. Configs. Relationship. There we go. That is done. Hey, Jean-Marc. How are you doing, my friend? So now we can go to the config resource. We can start to fill this in. Oh, do not disturb has turned off, which means I've been offline for roughly an hour. I will start wrapping this up. I believe my wife also has this school run really soon. Right, so our configuration. let's pass this through here. So our property read is going to be a shell config, and that is going to be our resource. So we're going to have the name of this specific, we're going to have the data returned straight away. This resource data. The shell is going to be a new shell resource. The resource we're going to pass back is this when loaded relationship of shell. So we can now come over to fit this one, where strict types, final class, clear that out, add our read-only property, and this is going to be a shell. That's resource. That here, I can just say that the name is type Steve type this resource name. And that's all I care about at that point, at that level. This could be expanded later on. Another story. That bit works. Sync controller works. Let's have a look, see if we can actually test this here. So we can register our device. Now we want to duplicate this. And we're going to rename this. And we're going to say register shell config. So shells register. What happens if I send that? Data is required, device is required. Awesome. So parameters. Device. I've registered my device. The identifier was PG123. I can grab that. Register shell config. Done. Now it's just the data. So if I just open up a new terminal quickly, I am going to cat, not that. I'm going to go to my dot files, or actually, I'm going to cat my Z shell RC. What I want is all of this stuff. This is what I want to be passing across. This is what's important when I'm talking about my environment. Ooh. No, I don't want that as a param, do I? Yeah, ooh, undefined array key 0. In exceptions, handle error, blah, 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 lots of errors. New shell for device. Okay, shell service. Let's go have a look. Let's open up our shell service. We're getting array key 0 anywhere. Shell to array. Let's just do a quick dyne dump on our shell. There. Steve's machine is lots of data. That's fine. Let's look at dyne dumping on name and data. Undefined array key 0. So this is having an issue. So name, that should be working. I'm assuming it is struggling with the data for some reason because of the way it's being sent. So it can't break that out for any reason. So that means with our payload, we need to do something slightly differently. So our new shell, what we want to do, we want the to array, but we're going to want to make these public. Because these are things that we're going to want to access programmatically. So that means I can delete that, and we're going to test that out now. We're going to dyne dump on shell data. Awesome. How about the name? Awesome. So I can get the shell name, get the data through shell data, and in theory, add fillable property device to allow mass assignment on that. Shell config, repository create, device ID, integrity constraint connection, blah, 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 blah. Okay, so that's failing to register it. So that means the way that I am sending it needs to change, which is fine. The app for API requests. This is HTTP bin. It's pretty cool. Let's open that in this one. I will drop the link in the chat. You might have used Notion, don't want that. HTTP. It is actually really nice. So I'm going to leave it there because I want to have a think about how I want to send that data over. Do I want to send it over as text and then just kind of process in the background and do my thing? Or do I want to process it CLI side? I'm not 100% sure, but I will have a think. Okay, so I'm going to go make myself a coffee and have a think about all of this. Thank you all for tuning in. Stay awesome. Have a great day, great morning, great night, whatever time it is. Stay awesome. Remember to like if you like the video. Drop a comment if you've got any feedback. I love feedback. Subscribe so you can always be notified for the next ones. Drop me feedback any way you can. Twitter, YouTube, you name it, drop it. I'm going to push this up to GitHub shortly, but for now, thank you.